Okay, so what we're going to take a look at is the last section in chapter 3, which is on graphing what are called absolute value functions. Does anybody remember what symbol you have? Like what the absolute value symbol looks like? What is it? How do you know that an equation has absolute value? It's got these, yeah?
2 brackets.
Yeah, they're like bars, right? So they look kind of like that. So you got those 2 bars, and then usually there's something inside them. Like you could just put an X. And if I hit graph, you'll see what it looks like. It's a V shape. So all the graphs that we draw today, they're going to look like V shapes. All right? I'm going to show you guys how to draw them. But let me zoom out a little bit. What we're going to look at is 4 different things we can do to that V shape. Like watch if I do this. I'm going to put +2. Does anybody notice what happened to the V shape compared to the way it looked?
It went up.
It went up. How many?
2.
It went up 2. So if you put a +2 at the end of the function, it moved it up 2. Now let's do a +2 inside. Anybody notice what happened this time?
It declines. Oh,
It's a positive slope
no, it
now.
goes to negative. It goes to the left.
It went to the left. Right? Originally the V shape was right here, and it went left 2. So depending on where you put a plus or a minus, you can move it up, you can move it down, you can move it left, you can move it right. All right? You could also do something like, let's do this. Let's put a 2 in front of the x, but multiplication.
What is happening?
What happened to the V shape now?
It closed.
It kind of closed up a little bit, right? It got skinnier. All right? So those are basically the 4 things we can, or however many you want to think of it. You can move it up and down. You can move it left and right. You can make it skinnier, or you can make it wider. Right? Those are the different things we're going to look at. So I got a little, when we get to it, I've got a chart that basically tells you where you put each number, what's going to happen if you put the number in that spot. If you put it inside, if you put it outside, things like that. So this little chart is basically what you're going to need when you do the take home. All right. So, yes.
There's so much time, right?
What's that? Yes. So, big idea is we're going to try to figure out what happens if you put a number outside. What happens if you add or subtract a number inside? Right? And I kind of tried to show you guys that. Like sometimes it moves it up, sometimes it moves it down. We've got to figure out kind of a pattern for what happens when.
Mr. Hager, that looks confusing.
That's okay. We're gonna go through it step by step.
Okay.
Hopefully it'll make sense. So an absolute value function. Okay, and I think this part, you guys can just look at this part. Absolute value function is basically anything that has an absolute value in it, like this. That's an example of an absolute value function. If you want to write down that example, you can. But we're going to do lots of examples, so you really don't need to write down one. So where it says the simplest absolute value function, okay, the first line on your guided notes, you want to write that in. So you guys got the first part. The simplest absolute value function that we compare everything else to is called the parent function. Okay, so the simplest absolute value function is called the parent function. It's basically just the simplest one you could have. Right? You don't have anything like plus a number, minus a number. All you've got is y equals absolute value of x. And that's the first one that I tried to show you guys. Just
Why is it so small?
like that. That's called the parent function. Nothing fancy, no other numbers, just y equals absolute value of x. And that's what it looks like. Hasn't been moved up, hasn't been moved down, hasn't been made wider, hasn't been made narrower. It's just the basic V shape without anything done to it at all.
Are we gonna have to do stuff with the calculator?
No, we're not going to use the calculator today.
Okay.
No. So, an absolute value function has a point called a vertex. And you guys got this little picture, and it's already labeled for you. The vertex, it's like the point on the V. Right? It's where it changes direction. Right? So you guys have got this picture. You don't have to write anything for this top part right here. But the vertex is just where it changes direction. If you want to put that off to the side in parentheses next to vertex, changes direction here, you can. But that's why I gave you guys the picture so you could see it. All right, now let's look at our domain and range. So remember, domain is how far the graph goes left and right. If you draw a V, how far does a V shape go left and right in that picture? Yeah, it just keeps going, right? If we were to zoom out more, a V shape just keeps going. It doesn't just stop all of a sudden. So if it goes on forever, then this is how we say the domain. It's basically all real numbers. What that means is it goes on forever, left and right. How about a horizontal line? Does that go on forever, left and right? Yeah, horizontal line goes on forever, left and right. So that's also all real numbers. How about a vertical line? Does that go on forever, left and right? What do you think, Blake?
Yeah, no.
No, vertical line doesn't. That's different. All right. How about a slanted line? Does a slanted line go on forever, left and right? What do you think, James? Yeah. So that's kind of like this one. So that domain of that would also be all real numbers. Now, range is up and down. Look at that V shape. Does it go up and down forever? What do you think? Lucas, what do you think?
Up.
Just goes up, right? The V shape doesn't go down. So the range here is every number from this point up. What does it look like the lowest that the V shape goes is? Adrian? What's the lowest that it looks like that V shape goes? Yeah, it goes to 0. Right? That's the lowest that it ever goes. So the range is all numbers greater than or equal to 0. Right? That's the range. 0 is the lowest, and it goes up forever. And that part should kind of make sense because think about what absolute value means. When you take the absolute value for a number, you never get what kind of answer?
Negative.
You never get a negative. That's why here, this graph never goes in the negatives. Because anytime you take absolute value, the answer is always positive. That's why this graph goes up. Right? It doesn't go down. Yeah?
But is it still positive when it goes to the left?
Yep, so that's over here. Remember, this is a negative x value. That's like asking this question to you. You can plug in a negative value, but when you get an answer, it's going to be what?
Positive.
It's going to be positive. Right? So this is your x value. That's what you plugged in. This is your y value. So for x, you can plug in any number you want. I don't care what number you tell me, I can always take the absolute value of it. But the answer that I always get will be positive. Okay, I will never get a negative answer for absolute value. And that's why that graph looks the way it does. All right. So you guys have a little chart, okay, that says when describing transformations. All right. So when we describe a transformation, there's 6 different things that could happen to your graph. Okay? I tried to show you guys a couple. Like it could move up, it could move down, it could move left, it could move right. Okay? I'm never going to give you a problem that has all 6 in the same problem. Right? I'm going to give you a problem like that. This one has one thing that's happening to it, a +3. Your job is just going to be to tell me what that +3 does. This one has a 2, just one number. All I'm going to want to know is what does that 2 do? That's a 2 in front of the absolute value. So this chart is going to tell us what happens, like if you put a 2 in front of the absolute value. Okay, so let's take a look at it. So we'll start with the first 3. Box number 1. That's right there. Box number 1, what that box does is it takes your V shape and it moves it to the left or it moves it to the right. And if you're wondering which way is which, I know it sounds a little weird, but a positive number in that box is going to move it left. A negative number in that box is going to move it to the right. So I haven't told you like what this box, or this box is going to do. Not yet. Don't cross them out.
Wait, so
All I'm telling you that is if you put a number in that box, it's going to move your graph to the left or to the right.
so that box is like the horizontal.
Yep, that box is what we call, that's the horizontal box. It does move it left and right. Here's an example. Y equals x plus 4. Let's look at it. So, I put a number inside the absolute values in that box right there, box number 1. Okay, I put a +4. So, that graph would move 4 units. Because it's a positive number, anybody tell me which way that the graph would move? Left. Positive is going to move left. Let me show you guys. So, there's the original without a +4. Now let me put in a +4 and hopefully it moves 4 units to the left. Let's see. So x plus 4, hit graph. Did it move 4 units to the left? Yeah. If you look at it, 1, 2, 3, 4. I'm just looking at where the tip of the V is. It went 4 to the left. So we just practice looking at where we put a number. What does it do? Okay, that moved it to the left. Okay, the next box, box 2. That would be if you put something in front of the x, still inside the bars. Okay, still inside the bars, but now it's a number in front of x. That's called a horizontal stretch. Okay? That's where the V shape can get like wider or narrower. Right? There's actually 2 things that can make it wider or narrower. That's one of them. Any question on that one? So that one in the front there is called a horizontal stretch. Okay? And down below, it says how to describe stretches, because describing a stretch is a little tricky. It's not as easy as like this one, just saying left 4. The stretch is a little weird, so I'm gonna explain that down below. Okay, so I'm not gonna explain it yet. All right. Third thing that can happen. Okay, same box, but if that box has a negative number in it, okay, what that causes is your graph to flip. Okay, it causes it to flip. Right. So when you guys for line 3, I'll make it a little bigger. On line 3, you want to put horizontal reflection. You can also write horizontal flip. It means the same thing. Yeah.
Can I go to the nurse?
Yeah. So horizontal flip means it's like a mirror image. Here's an example of a horizontal flip. Let's say you had, you know what, let me do it like this because it's easier. Horizontal. Let's see, if you had a shape like, that's going to look the same if I flip it. Yeah, let's do the letter B, because you can see the difference. That's a horizontal flip. It flipped left to right. Does that make sense, horizontal? It's like a mirror image. Now, the thing with a V shape is sometimes you can't tell if it flipped, because a V shape kind of looks the same if you flip it. All right. But sometimes you'll be able to tell. So notice box 1, 2, and 3 all start with what word? They're all horizontal, and that's because they're all inside the bars. Anything inside the bars does horizontal stuff. So if inside the bars is horizontal stuff, what do you think outside the bars is going to be? Vertical. Okay. So 4, 5, and 6 are all vertical. And we're going to have the same things. Shifts, stretches, and reflections. All right, so let me just do that so you guys can see it. Okay, box 4. Right, that's box 4. Right there. It's putting a number in front. Okay, putting a number in front of the bars. So we're gonna do an example of each one. Okay? But a number in front of the bars would look something like this. A 2 is a number in front of the bars. That's an example of that one. Okay, when you put a number in front of the bars, that's called a vertical stretch. Okay, and I'm going to show you guys exactly how to describe it. Okay, in 1 second. Now, when we talked about horizontal stretch, the next thing we talked about right after was a horizontal reflection. And that happens if the number in the box is a negative. Exact same thing here. Box 4 is a vertical stretch. If you put a negative in that box, it also causes what's called a flip, okay, or a vertical reflection. All right, so let me go back here for a second. That was a horizontal reflection. This is an example of a vertical reflection. That's vertical. Imagine like folding a piece of paper right here. If you folded it, that triangle would land exactly on top of that other one. Any question on that idea? What that one is? Okay, that's called a vertical reflection. Okay, and then the last box, box 6, you don't have to call it box 6, but it's already got an arrow to it. That moves your graph up or down. Okay, so the 3 big things we can do to a graph is we can shift it, we can stretch it, or we can flip it. Stretch, shift, flip. And the stretch, the shift, and the flip can either be a horizontal, or the stretch, shift, or flip can be a vertical. Okay? So we have to decide which one it is. Okay? Remember, horizontal stuff is always inside the box. Vertical stuff is always outside. And even if you don't remember, you can use this chart on the test. So all you have to do is look at the example I give you and then figure out, okay, he put a number in box 1. Look up what box 1 means in this chart. So shifts are easy to describe. All you have to do is say like left 2, right 2, up 5, down 6. You just have to say that. That's all you have to do to describe a shift. Reflections are also pretty easy to describe. You write it exactly like this. Flip over y-axis, or flip over x-axis. That's all you have to say. The stretch, a little weird. Okay, so I'm going to show you guys how to describe a stretch. Let's start with vertical stretch. Okay, what box is, or what number is the vertical stretch? Yep, that's a number in box 4. So this is how you describe a vertical stretch. Let's just write down, you know what? Yeah, that's what you want to write down. This is the most important part right here. So if you put a number in that box that's bigger than 1, like this, a 5, what that would do is it's going to cause your graph to basically get 5 times as tall. Think about if somebody stretched you out vertically. You'd get taller, right? You'd get taller and you'd get skinnier. Think of like a piece of gum. If you stick it to something and then you stretch it out, think about what happens. If it stays stuck where it's on the bottom, the strand of gum gets tall and it gets really skinny, right? That's basically what happens to the V shape. If you stretch it, it gets tall and skinny. But instead of stretching it, you could also squish it. Right? Think about what happens to like a piece of Play-Doh. Right? If you put it on a table and you push down on it, it gets short and it spreads out. That's exactly what would happen to the V shape. If you put a number in front of the V shape that's a small number, like a half, right? A half would make it half as tall. Right? A 2 would make it twice as tall. Right? But doesn't matter what number you put. This is how I always want you to write it. Anytime we see a vertical stretch, that's the phrase you're going to write. Graph is stretched vertically by a factor of, and then we put a number. Graph is stretched vertically by a factor of, in this case it would be 5. If this was a 2, I would say something like graph is stretched vertically by a factor of 2. Right? That just tells you how much it's stretched. Okay? So that's how we describe the number in front. Okay. Which number is the other kind of stretch? We just did the vertical. So what box has the other kind of stretch? Jalea, what box has the other kind of stretch?
Reflection. 6.
So box 6, that's a shift. And we just did the vertical stretch. So which other one there is a stretch? Number...
1.
No, 1's a shift. 2. 2 is a stretch. Okay, box 2, which I didn't really write this one in here. But 2 is our other stretch. So we want to describe a horizontal stretch. This is what you want to write down on your guided notes. That's the most important thing that's in that box. Graph is stretched we're just going to put in the word horizontally. Graph is stretched horizontally by a factor of 1 over the number. So there's a lot of stuff to remember here. That's why I don't want you to try to memorize all this. Every time we have a problem, we're just going to go back and look at this chart. Okay, so there's one more thing, and then the whole rest of the class is just examples. So we're almost done with all the information. Yeah?
So we're supposed to write down nothing in the box.
You can write down both, but what's in the box is the most important.
But that's like, I was confused because it was already printed on our papers.
Oh yeah, you guys already have what's on the box.
Yeah.
So yeah, then the only thing you have to write down is that the dash.
Okay.
Yep. The part that says the graph is. So now what we want to talk about is how do we actually sketch an absolute value function? Well, it's a V-shape. Okay, every graph we do today is going to be a V-shape. So that's a little bit more complicated than just a line. With a line, all you need is 2 points, and you can make a line. For a V-shape, we're generally going to do something like this. We're going to try to get 5, okay? Because if we get 5, that'll give us a nice nice V-shape. Right? So that's going to be the goal. Try to get 5 dots. All right, the last thing before we look at some examples. So, in order to graph a V-shape, what you guys are going to do is you're going to make a table. Okay? So we're going to make a table. We've done a table a lot. Okay, we make tables for different things. We're going to make a table for this. All right, so step 1. You have to decide what values for x you want to use in your table. Remember, when you are graphing an absolute value, you could use any values you want. The problem is if you use values that get too big, it's going to be kind of hard. So we don't want to use values that are too big. We don't want to use values that are too small. This is going to help you figure out what values to use. Okay. How many dots did I say we're going to try to get when we draw a V shape?
5.
Yeah, we're going to try to get 5. Step 1 is going to give you the middle x value. So this is actually our first example, and you guys, we're going to do it together on the bottom half of the front. Okay, so step 1, set what's inside the bars equal to 0 and solve. We're going to find 5 values. This one is going to be the middle. That one will be the middle. Okay, so if we look at that example, Maya, what's inside the bars there?
X minus 2.
X minus 2. And Leilani, what does it say to set what's inside the bars equal to?
0.
It says to set it equal to 0. Yep. So set what's inside the bars equal to 0, and now solve it. Tristan, how would I solve that?
Add 2 on both sides.
Add 2 on both sides. And when I add that, Tristan, what do I get?
X equals 2.
X equals 2. Right, so now reading those steps, 2 is going to be my what value? Which x? About Caleb? 2 is going to be my what value? Well, what does it say? Use this number as the
Slope.
no slope. Yeah.
It's going to be an x value.
Which one?
The middle x.
The middle. Remember, we're gonna have to find 5. That's gonna be the middle one. So if we had to find 5 numbers, there's 1. You get the middle one. So we need a few additional x values. What you want to do is pick 2 numbers that are smaller than that, and then pick the 2 numbers that are bigger than that. Right, so now we'll write them all in a table, and you guys get this same table in step 2. So pick 2 x values that are smaller and the 2 x values that are larger. Okay, so 2 is in the middle. What's the next number that's smaller than 2?
retake my test this period?
Yeah. What's the next number? What's the number that's smaller than 2? 1. What's the next number that's smaller than 1? 0. Okay, so it says to pick the 2x values that are smaller, and now the 2x values that are bigger. What's bigger than 2? Next number bigger than 2. Yeah?
3.
3. And the next number bigger than that.
4.
There you go. That's how you're going to get the x values in your table. We get the one in the middle, and then we get 2 smaller and 2 larger. All right, so that's the hard part, just figuring out which x's to pick. Okay? That's all I'm going to do for step 2. What column haven't we filled in yet? Yeah, we haven't filled the y's in yet. Well, that's step 3. Calculate the y values. Okay, so we've got our x's. We're going 0 through 4. How do you get a y value if you have an x value? What do you do with the x value?
Cancel it.
So we've got a formula, and we got the formula. The formula is right there. So what do we have to do to get the y values if we have a formula? Yeah.
Plug in for x.
Yeah, plug in for x. So our formula is m of x equals absolute value of x minus 2. Remember, m of x or f of x or anything of x, that's really just like writing which letter? Y. Okay? It's just like writing a y. So let's plug in each number one at a time, and we'll get our y values. Lucas, what's my first x value to plug in?
0.
Yep, 0. How about Julia? What's 0 minus 2? And what's the absolute value of negative 2? 2. My next x value is, Joe, what's my next one?
1.
1. What's 1 minus 2?
Negative 1.
Negative 1. What's the absolute value of negative 1?
1.
1. Perfect. Gianna, what's my next x value? 2. What's 2 minus 2?
0.
And what's the absolute value of 0?
0.
0. Now, watch what happens with the next two answers. Okay, you've already kind of done them. Elizabeth, the next x value is 3. What's 3 minus 2?
1.
And the absolute value of 1?
Negative 1.
No.
No. What's that? Absolute value is always
Oh, 1.
positive. It's the same number you just got right there. Just think about a v. It's going to be symmetrical. So you're going to get the same answers. Let's look at 4. What's 4 minus 2? 2. And what's the absolute value of 2? 2. That answer is going to always match that one. That answer is always going to match that one. So technically, once you do the first part, the second part's already done. Right? That'll happen because of how I had you guys do step 2. Always. Yep.
Okay, so when you're doing this, you would do 0 minus 2, but then you would do, when you get negative 2, but then it would be an absolute value.
So it makes it 2. Yep.
Okay.
Okay, so our last step now is to draw it and describe how, and basically describe what this minus 2 did. So we're going to look at our chart in a second that we just made. It's a minus 2 inside the bars. So keep that in mind. All right, so let's scroll down. So, how does, let's see, I might have to change the word. So this should be an M. How does the graph you just did compare to the original? All right. So we're going to have to look at what that number did to it. Might be easier if we draw the V shape first. Okay, I think to answer all these questions, I'm gonna draw the V shape first. So I've got the point 0, 2. It's one dot. 1, 1. It's another dot. 2, 0. Got one right there. 3, 1. Put one right there. And 4, 2. So there's my V shape. Now, if you remember, the vertex, that little point on the V, was normally at the origin. If you remember that, you can almost just look at that and tell which way it moved. Anyone think they can tell me which way it moved and how many it moved? Yeah?
To the right, 2 points.
Exactly. That's exactly how it compares. All you have to do is say, move right 2 units. Now, let's say you didn't have the picture and you couldn't tell. Look at what's in the parentheses. A -2. Let's go back and look at our chart. Follow the arrow back. We have a number right there. It's a -2. Okay, that's a horizontal shift. And it says negative. Let's see. Negative is going to move it. Hold on, let me go back to our graph for a second. Look at it. So negative is going to move it. Yeah, that's what we had, right? It moved it right 2. And is that what the direction said would happen? Yeah. Negative moves it to the right. Right? What do you think would happen if it was, what if I had a +2 right there? Which way would the graph have gone? Which way?
Left.
Yeah, it would have gone left. Right? Why? Because if you look at your chart, if the number in box 1 is a plus, that's a shift. Positive means left. Positive means left. Negative means right. Ours was a -2. All right? So don't try to memorize what the numbers do. Just go back and look at your chart. Okay, so let's write that in. Move right 2. That's all you have to write there. So it's basically, what did you do? You moved right 2. Now, I'm going to ask you the same question I did about domain and range for this one that I did on the original. Yeah. Yeah. Okay. Now that you move the V shape to the right 2 units, the domain is how far this graph goes left and right. Who can tell me how far that this V shape is going to go to the left and to the right? James? Forever. Yeah. In fact, anytime I ask you guys a question about the domain of this, all you want to write is all numbers. Doesn't matter what you do. If something goes to the left and the right, and you move it left a little bit, it still goes to the left and the right forever. If you put your V shape over here, it's still going to go left and right forever. Doesn't matter where you move it. Right? It's still going to go left and right forever. Now, how about up and down? That's the range. Does this graph go down forever?
Nope.
No. All right? Then if it doesn't go down forever, then that means it goes down to a point and that's it. It doesn't go any lower. So what's the lowest that this graph goes?
0.
And what's the highest?
Infinite.
Infinite. It goes up forever. All right? So the lowest it goes is 0, and then it goes up forever. So your range, all numbers. I'm just going to use the symbol. Greater than or equal to 0. That's what every problem in this section is like. Okay? So it's really 4 parts. Draw a picture, describe it, and then domain and range. Okay, so we don't have anything else new that I'm going to talk about in this section. We're just going to practice different examples by putting numbers in each of those boxes and figuring out what they do. But I'm never going to give you a problem that has all the numbers in all the boxes at the same time. That starts to get a little confusing. Let's take a look at this one. Example, the one we just did, I'm going to call that example 1A. So this is 1B. Okay. So you've got 3 lines, just like we did in the last one. Compare, domain, range. Easiest thing to do first is draw a picture. Because at least if you get the picture, then you can see. All right? So I'm going to make a table. How many values am I going to get in that table to draw this picture? We're going to get 5. The first thing we do is get the middle one. And then we'll go 2 lower, and then we'll go 2 higher. Let's look at the middle one. Set what is inside the bars equal to 0 and solve. Here it was x minus 2. What's inside the bars here? Inside the bars. Just x. And what are we supposed to set it equal to? Supposed to set it equal to 0. Is there anything to even solve in this one? No. Because what was inside the bars was just an x. It's not like it was an x minus 2 like it was in this one. There's nothing you have to do here. So that is your middle value. 0. What's one number lower?
Wait, how'd you get the x equals 0?
We just set what was inside the bars equal to 0.
Oh.
Last time we had a little bit of work to do when we did that. This time we don't. So what's one number lower than 0? Yeah?
-1.
What's one lower than that? All right. Now I want one number higher. And another number higher. 2. Now remember, this number is going to be the same as that one. This number is going to be the same as that. It's always going to happen. Let's plug in -2 for x. How about, Gianna, if I plug -2 in for x, what's the absolute value of -2?
2.
Plus 3? 5. Perfect. You get 5. Princess, what's the absolute value of -1? 1 plus 3? 4. All right, let's do 0. Sophia, what's the absolute value of 0?
0.
Plus 3?
3.
3. Now we should see the same numbers again. Blake, what's the absolute value of 1?
1.
Plus 3?
4.
4. And who can tell me what the last number is going to be without even doing it? It's going to be 5. Okay. Now graph those points and let's see where our V shape is. -2. 5, that's the first one. -1, 4. That's the second one. 0, 3. And once you get that, it's a mirror image because it's a V shape. 1, 4. And 2, 5. Here is your V shape. I didn't draw it perfect, but you get the idea. Good enough. Now, without even going back to the chart, I bet somebody can figure that out. Anybody tell me what happened to my V shape? It moved a certain way, and it moved a certain amount. And you could say it in 2 words, like blank, blank. Yeah?
It moved up.
Up 3, exactly. The V shape would normally be down here like this. Normally you put the tip right at the origin. This one, it went up 3. Now, let's say you didn't know that. You looked at the graph and you're like, nah, I'm not sure. Plus 3. Is that plus 3 inside the bars or outside? Outside. Okay, let's take a look at this. You're looking right there. It's at the end of the bars. It's in box 6. Look at what box 6 does. Vertical shift. Vertical means either up or down. How do you decide which one? Positive is up, negative is down. What did we have? A plus, how much was it?
3.
3. So we had a plus 3 in box 6. Plus 3. Up 3. Because it's vertical. So that's how you could look at your chart and figure it out. Okay, so let's put that right here. So move up 3. Now, notice this time I used h of x. Last time I used m of x. I might use f of x. It doesn't matter. It doesn't matter what letter you use there. Okay, now the domain. What did I say the domain was for every absolute value function?
All numbers.
All numbers. It's a V-shape. V-shapes are always going to go left and right forever. You can't change that. So just put all numbers. Now range is up and down. Does this graph go down forever? No. Then that means it has a lowest value and that's it. It doesn't go any lower. Look at that V-shape. What's the lowest that V-shape ever goes? 3. And then how high does it go? Just keeps going. So the range here is 3 up forever. So you want to write all numbers. And again, I'm just going to use the abbreviation, greater than or equal to 3. It's not 0 because you shifted it up. So this is the lowest that it goes, right there. And that's it. So I know it seemed a little confusing, probably when we go through all that at the same time, but hopefully that kind of starting to make a little bit of sense. And this is all we're going to do. We'll just practice. We'll practice like a few more of these. I'll practice them with you because they can be a little. They're a little tricky sometimes to do on your own. Any questions on this one? All right, let's look at this one. Graph it and then compare. A 2 in front of it. I just want to see if we can figure out what this is going to be before we even draw a picture. A 2 in front of the box. Anyone think they can tell me what it does if you put a number in front of the bars? That 2 was not inside the bars, it was in front of the bars. It was the very first thing. So what does that do? Yeah? Yep, and which box is that? In that diagram right here.
Box number 1.
No, it's in front, right? This is in front of the bars. So what's the box that's in front of the bars? Not inside the bars. In front.
4.
4. This is a box 4. Okay, we're putting a number in box 4. We're not doing anything to box 1, 2, and 6 in this problem. Okay, nothing. We're putting a number in box 4. Look at box 4. That's a vertical stretch. So we just learned how we're going to describe that. We're going to write this in the very end. Graph is stretched vertically by a factor of, and then we just have to write the number. So let's get that out of the way first. What's the number in front here?
2.
2. So this is what you want to write right here. Graph is stretched vertically by a factor of. That's the same in every single vertical stretch problem that you write. That's how it always starts. Now fill in the blank. Graph is stretched vertically by how much? In this case, 2. And if you're like, where did you get that graph is stretched vertically from? I got that from right here. Graph is stretched vertically by a factor of number. You had to figure out that this is what it was. You had to figure out that it was box 4. Okay? But we knew that because it was a number in front of everything. Anytime you put a number in front, that's always a box 4. Vertical stretch. And that's how you write vertical stretch. Okay, let's see. How about the domain? Before we even graph it, we should already know that. What's the domain going to be? Well, Olivia?
I have no clue. Oh, all numbers.
All numbers, right? Doesn't matter. I don't care if you take the V and you stretch it out and make it real skinny. I don't care if it looks like this when
does
you're
it
done.
always say that?
Yep.
Okay.
It's going to stretch vertically. So this V is going to get skinny, right? We talked about that. Take a piece of gum and stretch it. It gets tall and skinny. It's still going to go left and right forever. It's still a V, right? It's not as wide as it was, but it's still a V shape. V shapes still go left and right forever. All numbers. So I'm showing you guys, you can figure out most of this without even doing a picture. Right? The range, I think it's easier to look at the picture and then see how low it goes, and then go up from there. Right? So let's make our table now. Okay, how do I get the middle x value? What do I do to get the middle x value? James?
Is it the absolute value of x?
Yeah, take set what is inside the bars equal to 0. So Maya, what's inside the bars here? Just x. And what am I setting equal to?
0.
0. Is there anything to solve there? No. When x is the only thing in the bars, that makes the problem easier. There's nothing else to solve. Now, what's the next number smaller than 0?
-1.
Smaller than -1?
-2.
Bigger than 0?
1.
Bigger than 1?
2.
There you go. These two should be the same. Those two should be the same. Now we plug in our x's and get our y's. Blake, if I plug in -2, what's the absolute value of -2?
1,
Absolute value of -2?
2,
Times 2.
4.
4. Jaden, what's the absolute value of -1?
1,
Times 2?
2.
2. Right. John, what's the absolute value of 0?
0.
Times 2?
0.
Still 0. The next one is going to be, without even doing it, what's it going to be? 2. And the next one?
4.
4. Let's make our V shape. 0, 0. I just did that one first. We got to do them all. -2, 4. Right there. -1, 2. Right there. Let's see. 1, 2. And 2, 4. There's your V shape. Now, if you compare that to one of the ones we did earlier, look at that one. Look at that one. It got skinnier. That's what happened. It got stretched out. Now, does it go up? Does it go down forever? Start with that.
No.
No. What's the lowest that it goes?
0.
Lowest it goes is 0. Does it go up forever?
Yes.
Yes. So the range, all numbers greater than or equal to 0. It goes from 0 up forever. And that's it.
So it never goes below 0?
It never goes below 0 unless it flips. Remember, we talked about it could flip. I haven't given you one with a flip yet. But you'll know if it flips because box 3, or this box right here, will have a negative, or that box will have a negative. But I haven't given you one when it flipped. A flip would look like this. That's a flip. It's upside down. And in that case, yes, it would go down forever instead of up forever. But we'll see if we do one like that.
Can I do it?
Yeah. All right, let's look at, we're gonna do a flip in a minute. Okay, but let's do this one first. Example 2b. Okay, let's make our table. I feel like let's just do the table first. Okay, how do I get my middle x value? Someone tell me, how do we've done it 3 or 4 times now. What do I always do to get the middle? Yep.
You multiply
Set what's,
by 0.
set, yep.
You take what's inside the absolute value and equal it to 0.
Exactly. Take what's inside the absolute value and equal it to 0. Most problems I've given you guys, it's just an x in there. The first one wasn't, but this one is. That's your middle x. Is there anything here you need to solve? No, it's already solved. Smaller than 0?
-1.
Smaller?
-2.
Bigger than 0?
1.
Bigger?
2.
There you go. Those are your x's. Now let's plug them in. What's the absolute value of -2?
2.
2. Now they're saying take half of it. What's half of 2?
Oh wait.
1.
1. Now plug in -1. Absolute value of -1?
1.
1. What's half of 1?
0.5.
0.5. And remember, I'm going to think of it like that. 0. What's the absolute value of 0?
0.
And what's half of 0?
0.
Still 0.
Let's just say
What's the next one going to be?
0.5.
0.5. And the next one?
1.
1. Now, let's graph those points. Now, this is a number in front, but it's a fraction. So it's like, think of the Play-Doh on the table. You're squishing it down, right? It's going to squish down. It's going to spread out. That's what's going to happen. So the V shape is going to get wider. Right, let's see if that's what happens. 0, 0. -1. 0.5. -2. 1. 1.5 and 2, 1. Look at my V shape. Compare that V shape to the last one we just did. Tall and skinny, wider. Okay, it got wider this time. Okay, so look where the number is. The number is in front of the bars. Let's look at our chart. What box is it what box is in front of the bars?
vertical stretch.
Right, that's the vertical stretch box. Box 4. Vertical stretch. So now it says right here, graph is stretched vertically by a factor of, and now we just have to fill in the number. Okay, so let's write that. Graph is stretched vertically by a factor of how much? Joe? A half. So what that really means is it actually didn't even really stretch. It got half as tall. It actually squished down and got wider. But that's how we write it. Graph is stretched vertically by a factor of, and then you fill in the number. What's the domain?
All numbers.
All numbers. Even though it's wider, it's still going to go left and right forever. How about the range?
All numbers greater than or equal to 0.
Perfect. Lowest is 0, and then it goes up. So all numbers greater than or equal to 0. Okay, I'm going to skip around because I want to make sure we get to some ones that are a little different. Let's do this one. Okay, example 2C. Okay, we only had 3 left anyway after this one, but I might skip one. Okay, let's make our table. What's inside the absolute value bars? James?
X.
And what are you supposed to set it equal to?
0.
Set it equal to 0. Anything to solve there?
No.
Nope. 0. Smaller than 0?
-1.
Smaller? Bigger?
1.
Bigger?
2.
There you go. Same? Same. Now plug them all in. What's the absolute value of negative 2? 2? What's 2 times negative 2? Yep. Absolute value of negative 1. 1. 1 times negative 2. Yep. So we could actually do these right away. We just need one more. What's the absolute value of 0?
0.
And what's 0 times negative 2?
0.
0. Now, watch what's going to happen here. Okay, we've got that negative. All right, so I'll show you what's going to happen. We've got 0, 0. Negative 1, negative 2. Negative 1, negative 2. Negative 2, negative 4. 1, negative 2. And 2, negative 4. There's your V shape. Now, look in front of the bars. When you look in front of it, there's two things. There's a 2 and there's a negative. Two things. So let's look up what the 2 does. Okay, the 2 is in which box there? Yep.
2.
No, that's
Oh,
inside the bars. This is in front of everything. The 2 is in box
4.
4. Okay, so pretend that negative isn't even there. We're going to do this problem exactly the way you guys did this problem. The 2 graph was stretched vertically by a factor of 2. We're going to start by writing that. Where is it? So graph is stretched vertically by a factor of 2. And you have to write one more thing. There's a negative in front of the 2. So go back and look at your chart and see what that negative means. It's a negative in the front. So look at your chart. It says right here, if there's a negative, here. If there is a negative in box 4, what does it say happens? Yep. Flip which way?
Down. Negative flip.
So flip
Over the x-axis.
over the x-axis, exactly. Right? 4 and 5 both belong to that box. If there's a negative in that box, it tells you right there, flip over x-axis. And that's what you want to put at the end. Flip over x-axis. Right, so we had to write 2 things because there were 2 things, a 2 and a negative. Now, what's the domain?
All numbers.
All numbers. It's still a V shape, even though it's upside down. It's still going to go left and right forever. All numbers. Now, does this graph go up forever?
No.
No. That means that it has a highest value and it goes down forever. What's the highest value that the V shape hits?
0.
0. And it goes down forever. So the range is all numbers. Yep. When it flipped over, now 0 is the highest and it goes down forever. Yeah.
How do you know whether it's supposed to be vertical or horizontal?
Vertical or horizontal, you look back at that chart that we made. We'll do one more. Let's see. That one would be a horizontal, and then that was our last one. Let's do. These are both horizontals. Doesn't matter which one we do. Let's do A. You know what, if I have time, I'll do the graph last. Let's write the compare, because that's the hardest part. I think you guys are getting the hang of the graph. That part's easier. All right. There's a 2 in front of the x. Let's go back at our chart and look at what happens when there's a 2 right in front of the x. Is that 2 inside or outside the bars?
Inside.
It's inside, and it's right next to the x. What box is inside the bars, right next to the x? Box 2. So what is box 2? What is it called? It's what kind of stretch? Horizontal. So box 2 is called a horizontal stretch. Let's look at how you describe it. Graph is stretched horizontally by a factor of, and now we're going to write that. So let's put that in. Graph is stretched horizontally. And again, how did we know that? We had to look up what it meant to put a number right in front of the x. That was box 2. So graph is stretched horizontally by a factor of, and how does it say to write it? By a factor of 1 divided by number. This one you have to put 1 divided by number. You don't have to worry about y, that's just what you have to do. Okay, so look at our problem. What's the number in front of x? 2. 1 divided by number. That's how you do that one. The domain would be all numbers. And to get the range, we would have to graph it and then look at the highest and the lowest points. But I think you guys could handle finding the range. Just make your table, set what's inside the bars equal to 0. This time you got a little bit of work to do. What's 0 divided by 2?
0.
0. Now you make your table from there. And if you draw it, you'll see what it looks like. Okay, so homework, just going to be 4 questions. Basically 4 of just these. I'm going to have you guys skip question 5. Okay? Don't worry about question 5. We're going to do question 5 as the warm-up tomorrow. Okay? Actually, we'll do this example as the warm-up, and we'll do the one from the homework. So don't do question 5.